Kyle, let's look at problem 14 from the 2021 AMC 10A. All the roots of the polynomial z to the 6th minus 10z to the 5th plus az to the 4th plus bz cubed plus cz squared plus dz plus 16 are positive integers possibly repeated. Wow, that's long. What is the value of b? So it seems like going through all this is tedious, trying to factor this out, maybe divide it. The best approach here, it looks like, Vietta's formulae. So if you're not familiar with Vietta's, I encourage you to look those up. And in its simplest form, it says that the sum of the roots is negative b over a, which in this case is going to be this term over the coefficient of our leading term. So it's going to be negative times negative 10 over 1. And the product of roots is going to be c over a, or the constant term, 16 over the coefficient of the leading term. So we know the sum of the roots is going to be 10, and the product of the roots is going to be 16. So how are we going to get 6 numbers, and there's 6 roots? 6 roots, A, B, C, D, E, F. And so we want A plus B plus C plus D plus E plus F equals 10. And then A, B, C, D, E, F equals 16. And that seems kind of tedious, except upon closer inspection, we see 16 only has so many factors. So I'm going to make a sort of factor tree. And so, or we could just list out all the factors. Let's do that. We have 1, 2, 4, 8, 16. And those are the only real factors of 16. And so what are we going to do? We're going to figure out 1, 2, 3, 4, 5. There's only 5 factors, and we've got 6 roots, so at least one of them is repeated. All of these roots are going to sum to 10. So right off the bat, I know, hey, if I have 16 as a root, it's never going to sum to 10 because there's no negative numbers. They're all positive integers. So I have to cross 16 off my list. Okay, what if I have 8? If 8 is one of the roots, suppose a equals 8, then the lowest possible value for any of the other roots is going to be 1. And so if b equals 1, c equals 1, d equals 1, hey, wait, by this point the sum is already 11. And so we can't have it be 8 either. That's way too big. I think it can be possible to have 4. Let's try it out. What if we have a equals 4? And at this point, it's just kind of deductive reasoning where we're looking at what's feasible and what's not. So I could have a b equals 2, c equals 2, and by that time, I'm already at 16 without having added to 10. So I could go through and figure out if there's a way to sum to 10 and multiply to 16 with one of the roots or more than one of the roots being 4. But that is going to take a bit of time. If I go through all this, I realize that I'm going to have to stick to my smallest factors, which are 1 and 2. And I'm going to have to use 2 times 2 times 2 times 2. So 2 to the power 4, which is 16, times 1 times 1. And this doesn't change the product. But when I add it up, I get 2 plus 2 plus 2 plus 2 plus 1, which gives me 8 plus 2 is 10. So this is the only combination that works. 2, 2, 2, 2, 1, 1. Now I can actually just plug these back in, and I'm going to say that the polynomial is going to be z minus 1 squared times z minus 4 to the power, or my bad, z minus 2 to the power 4. And I can expand parts of this out so that I get closer to finding the value of b. And so I'm going to say this becomes z squared minus 2z plus 1. And this becomes z to the 4th minus 8z cubed plus 24z squared minus 32z plus 16. You double check that. Looks about right. And so the value of b, so b is going to be the z cubed term. So it's going to be any combination of a z squared term times a z term or a z cubed term. Those are the only values I can really have. Or, a z cubed term times a constant. All right, so let's multiply this z squared term by z term here. So it's going to be, the coefficient is going to be negative 32. And then a z term times a z squared term. So it's going to be negative 2 times 24. And then I'm going to have a constant term times a z cubed term. So negative 8. And so that gives me negative 88, which sure enough is option A. So if you don't quite understand what happened in the last step, I'm going to go over that really slowly. And I'm going to say, how do we get a z cubed term if we've got factor A and factor B? From factor A, I can get a z squared term. From factor B, I can get a z term. Or from factor A, I can get a z term. From factor B, I can get a z squared term. Or from factor A, I can get a constant term. And from B, I can get a z cubed term. Or from factor A, I can get a z cubed term. And from factor B, I can get a constant. And now, because I don't have any z cubed terms in factor A, this last one doesn't really matter. But going through these three, that's how I come up with this. And because I just want to find b, I'm just multiplying out and adding the coefficients to get what I would have for my final b.